From NASA balloon science to the discovery of enough water on Mars to cover its surface in an ocean 2 kilometers deep, and news that cosmology may not be in trouble after all, it was a great week for space news. Hey everyone, I post weekday space and astronomy news updates in 60-second bites, but if you missed the daily posts, here's the weekly edit of all the stories. If you enjoy the updates, please like the video and share it so we can spread the space science love. Have a great weekend. NASA is kicking off its annual fall balloon campaign at its Fort Sumner launch facility in New Mexico. An amazing breadth of astronomy can be done with balloon-borne experiments, and 16 missions will fly in the next month or so. These missions are typically shorter duration and will demonstrate technology that will be used on future long-duration balloon missions. For example, DRF-TES will test cooling systems and a gamma-ray detector, TIM will study galaxy evolution, TIE-SPICE will demonstrate a fine pointing system for balloon-borne telescopes, and Tin Man will launch a 60-pound payload designed to help us understand how thermal neutrons affect aircraft electronics. There are also 2 student platforms being launched, one carrying 12 student experiments and another that will demonstrate new hardware to double that capacity to 24 experiments in the future. In addition to all that, there are 8 piggyback missions that will ride along and squeeze even more science out of this balloon season. Find real-time updates and information at NASA's Columbia Scientific Balloon Facility website. Vast amounts of water have been detected 10 to 20 kilometers below the surface of Mars. The discovery comes from seismometer data on Mars quakes detected by NASA's InSight mission, which landed on Mars in 2018. Geophysicists built a detailed model of the interior of Mars that explains the varying speeds that Mars quakes travel through the red planet. The model shows the seismic waves pass through a layer of rock saturated with water, and the researchers estimate there's enough water present to cover the surface of the planet in an ocean 1 to 2 kilometers deep. These models are the same as those used to search for water or oil below the surface of the Earth. We think Mars was once covered in lakes, rivers, and oceans, but that those disappeared along with Mars's atmosphere about 3 billion years ago. Now it seems that not all of that water evaporated into space, and much of it drained down into cracks and pores below the surface. This is a super exciting discovery for those tracing the geological history of Mars, but will probably not provide a useful supply of water for future Martian explorers, since even on Earth, drilling down to such depths would be very challenging. Exciting news from the world of cosmology, where astronomers have used JWST to measure the expansion rate of the universe and found agreement with the expansion rate obtained when using the cosmic microwave background, or CMB, which is the relic radiation from the Big Bang. Astronomers have known the universe is expanding since 1929, when Edwin Hubble showed that distant galaxies are moving away from the Earth faster than nearer ones. The Hubble constant that we use to measure the expansion rate bears his name, and its value, calculated from the CMB, is 67.4 kilometers per second per megaparsec. Various other methods to measure the expansion rate directly have given answers as high as around 74 kilometers per second per megaparsec, leading some cosmologists to wonder if there was a problem with our cosmological model of the universe. However, these new highly precise JWST measurements, using 3 different methods to measure the velocities of nearby galaxies, all produce results that agree with the CMB value within the error bars. As always, more research is needed to confirm the results, but this seems like good news for the standard model of cosmology. While satellite megaconstellations promise various benefits to society, scientists have been sounding the alarm about the possible significant downsides for several years. SpaceX has plans for 40,000 satellites in its Starlink constellation, and many other countries have begun building similar arrays. Such satellites only have a lifespan of a few years before being replaced, and the default disposal method is to simply allow the old satellites to burn up in the atmosphere. Problem with this is that the satellites contain significant amounts of aluminum that turns into aluminum oxide when burned. This is known to damage the critical ozone layer and also affect how much heat Earth radiates into space versus how much is retained in the atmosphere. If all the planned constellations go ahead, within 10 years we'll be dumping 29 tons of aluminum into the top of the atmosphere every day with unknown consequences. This is because, surprisingly, the environmental impact of satellite constellations has been exempted from FCC review since 1986, a time when far less satellites were being launched. There's an interesting article with more details over at space.com. 66 million years ago, a large impact occurred in Chicxulub, Mexico, that coincided with a mass extinction event on Earth, including non-avian dinosaurs. Scientists have been debating for decades what type of object collided with Earth, with an asteroid being the most common, but more recent simulations from 2021 suggesting it could have been a comet. Now, scientists studying isotopes of the element ruthenium deposited in the layers of the impact site at Chicxulub have determined that it was indeed an asteroid, and one that formed in the outer solar system beyond Jupiter. The so-called C-type or carbonaceous asteroids are distinct from S-type asteroids that form in the inner solar system nearer the Sun, and also very different to comets in composition. Most asteroids that fall to Earth are of the S-type, so the result is super interesting for 2 reasons. Firstly, scientists think C-type asteroids may have brought water to Earth in the past, and secondly, if mass extinction events are linked to C-type asteroids, we have a better idea of where to look in the future for potential planet killers. That's a